This is Echoes, a U-Krant podcast. In it, Christien Boomsma, Rob van der Wal, and me, Tom Wilcox, introduce you to remarkable people and extraordinary events from 4 centuries of UG history. From persecuted Scottish students fleeing to 17th century Groningen to a Russian spy seducing a UG physicist. This is Misunderstood Genius, about Herman Haga and Cornelis who missed out on a Nobel Prize because their laboratory on the Westersingel was a little bit too modern. There is a photograph in the Groningen University Museum storage depot. It's a long rectangle, and in the space around it, someone has scribbled notes in a chicken scratch, the ink faded. The photo was shot in black and white, or rather black and brown, as it clearly dates from the 19th century. It shows a wide beam of light that starts at the top of the photograph. Halfway down, the beam widens and breaks up into a kind of fan pattern. "Very nicely done," it reads, "as long as it hasn't been tampered with, which I can't judge without seeing the original." There they were, Groningen researchers Herman Haga and his colleague and right-hand man, Cornelis. It was 1899, and they had not long before sent proof of a spectacular discovery to Wilhelm Conrad Röntgen, the world-famous scholar who 4 years earlier had discovered X-rays. Röntgen was an old acquaintance of Haga's, from the time the Groninger had studied in Strasbourg. The two had been corresponding on the question of what X-rays actually were. Particles? Light? Nobody knew. Until now, anyway. The photo, Haga thought, was proof that X-rays were a kind of wave, just like light. After all, any physicist would immediately recognize the fan pattern in the photo as an interference pattern. This happens when different light sources, or other phenomena with the properties of a wave, meet. Some waves coincide and make each other stronger. Others, however, do not and cancel each other out, resulting in a striation pattern. If Haga was right, his discovery was not only new, but revolutionary. But Röntgen was clearly skeptical. Would Haga and Wind have been angry about this reaction? Disappointed? They had a state-of-the-art laboratory on the Westersingel, the current location of the Noorderpoortcollege. For months they had toiled to get this result, and now this? When Röntgen had made his discovery known to the world 4 years earlier, everyone had thrown themselves into researching the mysterious rays that went right through clothes as well as skin. The new technology could be used to take pictures of the inside of the body. Researchers all over the world started doing experiments. They liked to take pictures of their own hands, in which the bones were clearly visible. Haga had done so too. His first X-ray photos were shown in Groningen just 3 months after Röntgen's discovery. He had already photographed a compass in its box, as well as a frog. These photos can still be found in the Groningen University Museum's storage depot. But after the initial enthusiasm, most had returned to their old work. But not Haga. He and his colleague Wind threw themselves wholeheartedly into their X-ray research. Not to use it for medical diagnostics, that didn't interest him much. No, Haga wanted to know what X-rays actually were. He put aside his research on geomagnetic radiation and focused completely on this new, fascinating field of research. Were charged particles moving through an X-ray tube? Or, Haga wanted to know, was it an electromagnetic phenomenon, something like light? And if it was it a wave? And if so, what was the wavelength? Cornelis devised the most complicated methods to find out. In Haga's laboratory, they dropped radiation through a narrow gap onto a second gap. They recorded the resulting interference pattern, the scattered radiation, on a photographic plate. While that may sound simple, it was anything but. The photographic plate was sometimes more than 10 meters away from the irradiated gap. The irradiation times were enormously long, sometimes up to 400 hours. and the wavelength, the distance between the dashes on the plate, was so difficult to observe that they had to measure it under a microscope. All of it only worked if they had a perfectly stable setup, because the slightest vibration could mess everything up. More than once, the pair thought they had captured an interference pattern, only to be proven wrong. In a lecture in 1899, Wind talked about how hard it was on him sometimes. Disappointment would gradually set in. Very slowly, like a grey spectre, it came over us, whether those dashes at which we had gazed for so long were perhaps the result of an optical illusion. And so it is perhaps not surprising that Röntgen also wondered whether Haga's photographs hadn't been tampered with, which also meant that there was some uncertainty around Haga's conclusions. After all, Haga did not just use his images to prove that X-rays were a wave. He also determined the wavelength, estimating it at 0.1 to 2.5 angstrom, 1,000 times smaller than ordinary light. It was too bad. It wasn't just Röntgen who had doubts about the results. Other colleagues in the field felt the same. They tried to reproduce the results, but no one was able to pull it off. There was a good reason for this. Haga's laboratory was very modern for the late 19th century. Because of his earlier research, it had been built on the site of one of the old city's bastions, a place where the ground was maximally settled and super stable. As an added bonus, pillars had also been installed separate from the foundation. Wooden floors resting on the foundation were shuttered to ensure that test setups weren't disturbed by the vibrations from people walking by. That was what allowed him to make those wildly accurate measurements with such extremely long exposure times. But that also ensured that no one could reproduce his results. Other researchers worked with gaps through which they dropped the radiation, optical grating and other setups, but their experiments experienced interference from traffic passing by their labs or the vibrations of passers-by. And so Haga's results were questioned or considered a clumsy miss. What must Haga have thought when years later, in 1912, German Max von Laue showed that X-rays were indeed waves and that their wavelength was quite close to Haga's calculation? Von Laue was awarded the Nobel Prize for it in 1914. And Haga? The latter had to make do with a quick mention in the speech after the ceremony. Haga and Wind proved that the X-ray beams indeed widened, which could be attributed to diffraction, von Laue told his audience when he accepted the Nobel Prize. Wind had died by then. Whether Haga was impressed by the mention in a speech that also mentioned numerous other scientists remains a mystery. He died in 1936. The laboratory of Herman Haga and Cornelis Wind was located on the Westersingel and is better known as the Castle. It is where Noorderpoortcollege is located today. The X-rays Haga took are still in the possession of the University Museum. This episode was written and researched by Jan Waling Huisman of the University Museum Groningen and Christien Boomsma. Sound by Rob van der Wal. Voice Tom Wilcox. Literature on Herman Haga and his research can be found in the show notes.